Time and material contracts offer several advantages. Firstly, they provide flexibility, which allows for unforeseen issues and changes as the work progresses. Secondly, they offer transparency. The homeowner can track the costs and labor involved, providing a clear picture of where their money is going. Thirdly, time and material protects the contractor, covering potential overages in materials or unexpected work that may arise during the project. However, there are also disadvantages to consider. Potential misunderstandings can occur because the total cost may not be clear upfront, leading to potential disputes between the homeowner and the contractor. There may be increased costs, with the homeowner potentially paying more than a fixed price bid due to unforeseen circumstances that arise during the project. Given the size and condition of the home, strongly consider offering a time and material bid. Several factors support this decision. The home still has significant knob and tube wiring, indicating the need for extensive rewiring to bring the electrical system up to current safety standards. The homeowner had partially replaced some wiring but not others, making it difficult to estimate the exact scope of work required to complete the rewiring project. The bid includes not only wiring upgrades but also repairs to the AC unit, doorbell installation, and fixture checks, adding complexity to the project. The attic and basement have poor lighting, making it challenging to fully assess the wiring and potential obstacles that may be encountered during the work. Time and material allows for flexibility to address unforeseen challenges encountered during the project, ensuring that the work can be completed effectively and efficiently. It provides transparency for the homeowner by allowing them to track the actual costs incurred, fostering trust and open communication throughout the project. It protects the contractor from potential overages in materials or labor due to discrepancies in the initial estimation, mitigating the risk of financial losses. Clearly explain the benefits and potential risks of a time and material bid to the homeowner, ensuring they understand the implications of this type of contract. Provide an estimate of the expected labor and material costs based on experience with similar projects, giving the homeowner a reasonable expectation of the overall cost. Ensure that the homeowner understands that the final cost may vary based on the actual scope of work required, managing their expectations and preventing misunderstandings. When dealing with electrical work, especially in older homes, it's crucial to address several key areas to ensure safety and code compliance. Consider the service entrance. Evaluate the condition of the service entrance conductors, the meter, and the main disconnect. Upgrade if necessary to meet the current and future electrical demands of the home. Look at the grounding system. Ensure the grounding system is adequate and properly installed, including grounding rods and connections to metallic water pipes. Install ground fault circuit interrupter or GFCI protection. Install GFCI outlets in all wet locations such as bathrooms, kitchens, and outdoor areas to prevent electrical shock. Consider arc fault circuit interrupter or PSI protection. Use of PSI breakers to protect against arc faults, which can cause electrical fires. Branch circuit wiring needs to be looked at too. Replace any remaining knob and tube wiring with modern wiring methods such as non-metallic sheath cable or NM cable. Check the panel board. Inspect the panel board for any signs of damage, corrosion, or overheating. Replace any outdated or unsafe breakers or panels. When replacing wiring, adhere to the National Electrical Code, or NEC, standards for conductor sizing, overcurrent protection, and wiring methods. Use appropriate wire sizes based on the ampacity requirements of the circuits they serve. Install correctly sized circuit breakers or fuses to protect each circuit from overloads and short circuits, following NEC guidelines. Securely fasten wiring to studs and joists using appropriate cable staples or supports. When installing new electrical fixtures, appliances, and equipment, ensure they are properly listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or UL. Verify that the voltage, amperage, and wattage ratings of the equipment are compatible with the electrical system. Install fixtures and appliances according to manufacturer instructions and NEC requirements. When repairing the AC unit, diagnose the cause of the circuit breaker tripping. Check for issues such as a faulty compressor, capacitor, or wiring. Ensure the AC unit is properly grounded. Size the circuit breaker and wiring according to the AC unit's nameplate ratings. For doorbell installation, choose a doorbell that is compatible with the existing wiring and voltage. Install the doorbell transformer near the electrical panel and connect it to a dedicated circuit. Run low voltage wiring from the transformer to the doorbell button and chime unit. When checking existing fixtures, fans, and lights, ensure they are properly wired and grounded. Verify that the fixtures are suitable for their intended locations. Check for any loose connections or damaged wiring. Confirm that the wattage ratings of the bulbs or lamps do not exceed the fixture's maximum wattage rating. When working on electrical systems, always follow safety precautions. De-energize circuits before working on them. Use insulated tools and wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Test circuits with a voltage tester to ensure they are de-energized before handling wires or components. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. When assessing the existing electrical system, pay attention to the following. Identify any signs of overloaded circuits, such as frequently tripping breakers or flickering lights. Check for any evidence of overheating, such as discolored or melted insulation. Look for any damaged or deteriorated wiring, such as cracked or brittle insulation. Test the operation of all outlets, switches, and fixtures to ensure they are functioning properly. Verify that all electrical boxes are properly covered and secured. When providing an estimate for the wiring upgrade, consider the following factors. Calculate the amount of wiring needed based on the size and layout of the home. Determine the number of outlets, switches, and fixtures that need to be replaced or added. Estimate the cost of materials, including wiring, conduit boxes, breakers, and other electrical components. Factor in labor costs based on the estimated time required to complete the project. Include any additional costs, such as permits, inspections, and disposal fees. Clearly communicate the scope of work and the estimated cost to the homeowner, addressing any questions or concerns they may have. Obtain all necessary permits and inspections before starting the work. Comply with all applicable codes and regulations, including the NEC and local electrical codes. Coordinate with the homeowner throughout the project to ensure their satisfaction. Provide documentation of the work performed, including wiring diagrams, inspection reports, and warranties. When working with knob and tube wiring, exercise extreme caution. Knob and tube wiring is an older wiring method that is no longer considered safe by today's standards. It typically consists of single conductor wires supported by porcelain knobs and run through porcelain tubes where they pass through wood framing. Knob and tube wiring lacks a grounding conductor, which can increase the risk of electrical shock. The insulation on knob and tube wiring can deteriorate over time, increasing the risk of fire. Avoid disturbing knob and tube wiring if possible. If it must be disturbed, to energize the circuit and carefully remove the wiring, taking precautions to avoid damaging the insulation. Replace knob and tube wiring with modern wiring methods such as non-metallic sheath cable or NM cable, which includes a grounding conductor and is more resistant to damage. Consult with a qualified electrician to ensure that the knob and tube wiring is properly removed and replaced. When selecting electrical materials, choose high-quality products that meet industry standards. Use copper wiring for branch circuits and feeders, as it offers excellent conductivity and durability. Select electrical boxes made of metal or durable plastic that are suitable for their intended use. Use circuit breakers and fuses that are properly rated for the circuits they protect. Choose outlets and switches that are tamper-resistant and meet safety requirements. When installing electrical equipment, follow manufacturer instructions and industry best practices. Install outlets and switches at the proper height and location. Securely mount electrical boxes to studs or joists. Make sure to properly tighten all connections. Protect wiring from physical damage by routing it through conduit or using protective sleeves. Label all circuits and equipment clearly and accurately. When troubleshooting electrical problems, use a systematic approach. Start by gathering information about the problem, such as when it occurs and what symptoms are present. Inspect the affected circuit and equipment for any visible signs of damage or loose connections. Use a multimeter to test for voltage, current, and resistance. Consult wiring diagrams and technical manuals to help diagnose the problem. When making electrical repairs, use proper techniques and materials to energize the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Make sure to properly splice wires using wire connectors or solder and tape. Protect splices from moisture and corrosion by using weatherproof connectors or enclosures. Test the repaired circuit to ensure it is functioning properly. When upgrading an electrical system, consider the future needs of the home. Plan for additional circuits and capacity to accommodate future appliances and equipment. Install a larger electrical panel if necessary to provide sufficient space for additional breakers. Consider installing a sub-panel in a remote location to provide power to a specific area of the home. Evaluate the need for surge protection to protect sensitive electronic equipment from power surges. Consider installing energy-efficient lighting and appliances to reduce energy consumption. When working on electrical projects, always prioritize safety. Never work on live circuits unless absolutely necessary, and always follow proper lockout-tagout procedures. Use insulated tools and wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Always double-check your work to ensure it is safe and compliant with all applicable codes and regulations. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. By following these guidelines, you can ensure that the electrical work is performed safely and effectively, providing reliable power and protecting the home from electrical hazards. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations in the United States. It is updated every 3 years to reflect the latest advances in technology and safety practices. Compliance with the NEC is essential for ensuring the safety of electrical systems. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for conductor sizing, conduit fill, box fill, and other aspects of electrical installations. Familiarize yourself with the NEC requirements that are relevant to the work being performed. Consult the NEC handbook for additional guidance and clarification. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and can also be accessed online through various subscription services.